So we're going to have a look at this question here. So it says sketch the graph of cot x minus 2. So there's two bits to this. First we need to think about what does cot x look like, and then what graph transformation is going to happen there. So I'd first of all just break it down and think, well, what does cot x look like first? Because we might not be as familiar with cot x. So to get cot, I'm going to work backwards sort of and start with tan. Well, I guess I don't know if that's start forwards or backwards, but I'm going to start with tan. So I'm just going to draw the graph of tan x down here. I'm going to draw it between minus 2 pi and pi. And the reason for that is when we do that transformation, if we think about it, that is a translation. And that means basically the graph's going to shift. So it might be helpful to us, and it will be, to see what's happening before we get to 0 on the x-axis. So let me just put in my values like so. So for tan, we should be able to draw a graph of tan x. So first of all, our asymptotes are going to be at pi over 2, 3 pi over 2, and then just continue at intervals of pi. I do always find it easier to do the positive first, and then from the negative, I just sort of follow the pattern. And then I know it starts like that, and that means the other side's going to look like that. And then obviously it shouldn't be touching the asymptote. So if I am drawing it touching the asymptotes, don't do that. It shouldn't touch the asymptote. Like so, and then it's going to do that and that. So that's tan x. So in blue, that's tan x. So now I'm going to do cot x. So cot x, remember, is just the reciprocal of tan x. Now you can remember what this looks like, or you can be lazy, or I'd call it efficient, and think about, well, what's happening there, because it's basically just, like say, the reciprocal. So what happens for values of tan x, because we can see what tan x is, because we've got our graph. So let's first of all think about what happens when tan x is 0 when we've got cot x. Well, that would effectively be 1 divided by 0, which we know it's not a thing, doesn't exist. So that means our asymptotes are going to be when tan x is 0. So we're going to have asymptotes here, here. So it's still like intervals of pi, but this time it's at 0, pi, 2 pi. So we sort of shifted where the asymptote is. Then we need to think about, again, what happens with tan and how that affects cot. So let's say cot is, so I'm doing 1 divided by a very, very small number. So we've gone a little bit past 1, but we're still dealing with a very small number. 1 divided by a very small number gives me a very large number out. So that means when tan is very small, cot is very big. So we're going to have cot up here when tan is very small. And then vice versa, when tan is very, very large, we're dividing by a very large number, so that means that cot is going to be very small. So it's going to look something like that. And then we're going to follow the trend for negative as well. So again, because if we divide by a very small negative value, we get a very large negative answer out, and vice versa. And when cot is negative, tan is negative, and when tan's positive, cot's positive. There's no sign changing. So that's sort of what cot's going to look like. And then we can then just sort of follow that pattern again, logically thinking when tan is small, cot is big, and the same for when it's negative. So here, very small value for tan, and then as tan gets bigger, cot gets smaller, and then we carry that on into the negatives like so, and then just keep doing that really. And then you can sort of see where the sort of tan is between, sorry, not the tan, but where the curve is between the asymptotes, and we sort of just repeat that then. So we end up with this. So that is what cot x looks like. So now I need to think about what is happening with that graph transformation. So the graph we want is x minus pi over 2. So let's think about what that's going to do to my graph. Well, it's a translation, isn't it? We're basically going to take all our x coordinates and add pi over 2. So then we shift the graph. We shift the graph to the right, if I've got my left and right correct. That's what we're going to do to our graph. Remember, if it's in the brackets affecting x, we basically do the opposite operation to what is there. So that means everything is going to shift over to the right, pi over 2. So the graph is shifting this way, pi over 2. So basically, we need to think, you can draw it all shift one, but I just like to think logically, okay, what's going to happen then? So 0, where x is 0, is now going to be, for our old graph, where x is pi over 2. Because if we add minus pi over 2, add pi over 2, we're at 0. And so on. And then that's going to go all the way up to 3 pi over 2. Because again, 3 pi over 2, add a pi over 2 gives us 2 pi. So that is the bit of the graph that I'm going to draw between 0 and 2 pi when it's been translated by pi over 2. So now all I have to do is draw that on my graph. So let's do that up here. I might have to scroll up and down so I can remember what it looks like. So I'll do blue again. So I'm just going to add in pi over 2 and 3 pi over 2 because that would make me happy. Having those sort of key values on there, I'm just going to check it's definitely 0 and 2 pi that it wants. Yep. So when the graph carries on, we only need to draw it between 0 and 2 pi. So that's all I'm going to do. So my asymptotes are at pi over 2 and 3 pi over 2, because remember they were at pi and 0 and all that, but again it's all been translated now. So asymptote here, asymptote here, and then my graph was down here, and then it was up here, going through 0 at pi, like so. Again, making sure your asymptotes do not touch the curve, and then it looks something like that. And that is the graph of, so that's y is equal to cot x minus pi over 2. And if I just check, does that correspond with what I did there? Yeah, we can see. So it starts at 0, it goes down to negative infinity. We've got our asymptote, and then it starts from infinity, goes back down through pi, was pi over 2, it's now pi, and so on. So yeah, that's what it looks like. So that is our graph.